Hello, I am Sunita. Welcome to my class. Here I will discuss Gpstr 2017 Maths and Science Solved Question Paper Part 2. Here I am going to discuss only science questions. Let us see first question. Which of the following is not a derived unit? Which one is not a derived unit among this one? Option A Newton, option B Joule, option C Watt, option D Kelvin. Before going to answer this question, first we have to know what is meant by a derived unit. A derived unit is a unit that results from a mathematical combination of SI base units. How you will get a derived unit? First we have to know the mathematical formula for particular quantity. Then we have to come to know the base units. Then combination of 2 or 3 base units we will get a derived unit. Let us discuss in detail. Here force is the quantity. What is the equation for force? Force equation is mass into acceleration. Then here for mass, what is the base unit for mass? Base unit for mass is kg. For acceleration, meter per seconds square. When you are combining these two base units, then you will get Newton. This Newton we will consider as a SI unit for force. Let us see next example. Energy or work. Formula for work is force into displacement. Already you know for force Newton is the SI unit. For displacement meter is the base unit. When you combine Newton meter, then you will get a joule. This joule we will use as the SI unit for either work or energy. Next one, power equation. Power is nothing but work by time. SI unit for work is joule, already you know. Then for time, second. When you combine these two base units, then you will get watt. This watt we will use as a derived unit for power. Therefore, first three cases Newton, Joule, Watt, these three are the derived units. But fourth one Kelvin. Kelvin is the SI unit of temperature. It is not derived from any combination of base units. This is the individual unit. This is the SI unit of temperature. This is not the derived unit. Therefore, the correct answer is Kelvin. This is not the derived unit. Next question. When a bar magnet tied to a thread is suspended freely, it option A comes to rest along earth north-south direction. Option B comes to rest along earth east-west direction. Option C come to rest along earth southeast direction. Option D come to rest along earth northwest direction. Direct question. When you freely suspended a bar magnet freely in the air, then normally it will come to rest along earth north-south direction. Therefore, the correct answer is it will come to rest along earth north-south direction. Let us see next question. Ohm's law can be written as, how mathematically you can represent Ohm's law? Here they are asking the question. Before answer this, let us discuss what is meant by a Ohm's law. Ohm's law states that electric current flowing in a conductor is directly proportional to potential difference across the end of the conductor, provided temperature and other physical conditions remain constant. Here in Ohm's law, current is directly proportional to applied voltage. When current increases, voltage also increases. When voltage increases, current vice versa. Both they are directly depends when one quantity increases, others also it will increases. Therefore, you are getting a graph. The straight line you are getting, it is passing through a origin. It will indicate when one quantity is directly proportional to another one, then you will get a graph like this. Here, one important point already I mentioned, the current and voltage, they are directly depends upon each other when a current carrying conductor. But here they are given the condition both temperature and other physical quantities remains constant. Therefore, we can derive this equation. I, it will be V by R. Here R is nothing but a resistance. This R we will call it as a proportionality constant. Therefore, the correct answer is V is equal to IR. You can rechange this equation. V, it will be equal to I into R. You will multiply. Then you will get this answer. Therefore, Ohm's law is nothing but V is equal to I into R. Then next question, the molarity of 4 gram of sodium hydroxide in 1 liter of its solution. Here you have to calculate the molarity of 4 gram of sodium hydroxide. Then first we will know what is meant by molarity. Molarity is the amount of a substance in a certain volume of a solution. Amount is nothing but how much quantity of a particular substance is present in given volume of a solution. Here they are given the example sodium hydroxide. Then 4 grams of sodium hydroxide when you dissolved in 1 liter of water, then what is the molar concentration of sodium hydroxide? That one you have to calculate. Let us see. Here they are given mass of sodium hydroxide is 4 gram. Already they mentioned the mass 4 gram. Then volume of water, they are mentioned here 1 liter of its solution. Therefore volume of water is 1 liter. First step, you have to calculate molar mass of sodium hydroxide. This is a molecule, sodium hydroxide. What is mean by a molecule? Molecule is nothing but a combination of atoms. Here you can identify 3 types of atoms. One is sodium, oxygen, hydrogen. To calculate molar mass, first we have to know the atomic mass of the individual. What is the atomic mass of sodium? 23. This one you have to remember. Atomic mass of oxygen 16. Atomic mass of hydrogen 1. When you add all the three, you will get 40. Then this 40 is nothing but molar mass of sodium hydroxide, otherwise molecular mass of sodium hydroxide. This is the first step. Then next step, what you have to do, then this one you have to convert in terms of moles. Mole is the standard unit, therefore you have to convert in terms of moles. Formula you have to remember, moles of sodium hydroxide mass divided by molar mass. Then here moles of sodium hydroxide, already they are given, mass is 4 gram. Then molar mass, now only you calculated molar mass 40. 4 divided by 40, 4 ones are 4 tens are 1 by 10 is nothing but 0.1 mole. This is moles of sodium hydroxide in 4 grams. Then next step, you have to calculate the molarity. Molarity of sodium hydroxide, this is the formula you have to remember. Moles of solute divided by volume of solvent. Then moles of solute, here 0.1. Then volume of a solvent, already they are given 1 liter. 0.1 divided by 1, you will get 0.1 molar. Therefore, here molarity of sodium hydroxide is 0.1 molar. Here formulas, important formulas you have to remember, then you have to substitute, then you will get the answer. Therefore, the correct answer is the molarity of 4 grams of sodium hydroxide in 1 liter of its solution is 0.1 molar. The next question, zero dipole moment is found in option A, NH3, option B, SO2, option C, H2O, option D, BF3. First we will see what is meant by dipole moment. Dipole moment occurs when there is a separation of charges. If you identify the separation of charges, then that case you will find dipole moment. They can occur between the two ions in an ionic bond. Dipole moment, it will occur even in ionic bond when there is a separation of charges present in an ions. Then between atoms in a covalent bond, this can observe even covalent bond also when there is a separation of charges in case of atoms if it is present. Then one thing here you have to remember, dipole moment you can observe both in ionic bond also and also covalent bond. Then here consider the case BF3. Already here I mentioned BF3 has zero dipole moment. Then why it has zero dipole moment? Let us discuss in detail. Here you can observe boron trifluoride. It has three polar PF bond. It has three polar PF bond. BF3 has sp2 hybridization. Here you have three polar bonds, and this bonds it will be formed by sp2 hybridization. Here you can observe. Then one bond is exactly upward. The remaining two bonds it will be in opposite direction. Then here the bond, the angle between the bonds is 120 degree. Here also 120, 120, 120, and here the regular triangular planar geometry. This it will be this the shape of the molecule is in triangular geometry. Then here one thing you can observe, the dipole moment of this upward bond, this polar bond, then the dipole moment of these two side polar bonds, they will get cancel each other. Why they will get cancel each other? See here, this polar bond it is pointing towards up, then these two is pointing towards down. When you sum up, otherwise the resultant polar dipole moment of these two downward fluorine atom, it will get cancelled with the upper one. It is showing upper dipole moment. The resultant it will be zero. They will be cancelled each other. Therefore BF3 has zero dipole moment. Here the important thing you have to remember is boron trifluoride, it has three polar bonds, and also it will involve sp2 hybridization, and the geometry is triangular planar geometry. Why the dipole moment, why it will get cancelled? Because the three polar bonds, the dipole moment of upper one it will be equal and opposite to the dipole momentum of down polar bonds, then they will get cancel each other. Therefore, the correct answer for this question is zero dipole moment is found in BF3. Next question, moment of O2 into the cell and CO2 outside the cell occur by the process of which process? It will involve the movement of oxygen into the cell and carbon dioxide outside the cell. The option A, osmosis, option B, transpiration, option C, diffusion, option D, glutation. Let us discuss in detail. Oxygen and carbon dioxide move across the cell membrane via simple diffusion. Therefore, the answer is diffusion. With the help of diffusion, the movement of oxygen and carbon dioxide it will take place easily. A process that occurs no energy input is driven by the difference in concentration on their side of the cell membrane. It will not, this process diffusion, it will not involve any energy when there is a difference in concentration of oxygen and concentration of different gases are there, then diffusion it can occur very easily. Here in this picture you can observe clearly, here the molecules are very closely arranged, therefore the concentration it will be more here. Here the molecules are very less, they are arranged far from each other. Therefore, momentum of atoms, otherwise motion of atoms from higher concentration to lower concentration, otherwise movement of particles may be from higher concentration to lower concentration. This one we will call it as a diffusion. Diffusion you can observe both in liquid also, gases also. It will, this diffusion you can't observe in the solid, because in the solid there is no movement of ions, it will takes place. For example, exchange of oxygen and carbon dioxide in lungs, this is one of the best example for diffusion. Molecules are ions moving from area of higher concentration to a lower concentration. Even molecules, ions, they can move from higher concentration to a lower concentration. Difference in concentration is the concentration gradient. When there is a difference in concentration, then we will use the term concentration gradient. Concentrations are equal if when there is a case, if both the case the concentration it will be equal, then that case we will call it as a equilibrium. Then here one thing you have to remember, movement of oxygen into the cell and carbon dioxide outside the cell, which process it will involve. The correct answer is diffusion. Through the process of diffusion only movement of gas it will be takes place. How it will move? It will move from higher concentration to lower concentration, and it does not need any energy for movement. Next question, identify the vector quantity in the following. Option A, volume. Option B, mass. Option C, momentum. Option D, density. Okay. Before discuss this question, we have to know two factors. One is scalar, another one is vector. Scalar is nothing but it has only magnitude. Magnitude is nothing but a number, that is only magnitude. But vector in physics a quantity that has both magnitude and direction. It will show even magnitude also, even quantity also it will show, and it will show even direction also. Okay, here we will consider momentum as a vector quantity. In detail we will study why momentum we will consider as a vector. Momentum is nothing but a product of mass of a particle and its velocity. Momentum, it is a product of mass and also its velocity. It is a vector quantity. It has both magnitude and direction. Here, consider an example. Here a car, mass of the car is 1000 kg and it is moving with a velocity 16 meter per second. When the car is moving from one place to another place, consider from Mysore to Bangalore, it will show the direction. Here you can observe it will show the direction in which direction it is moving. Then momentum we will get mass into velocity. Mass is 1000 kg and velocity is 16 meter per second. Then you will get momentum 16,000 kg meter per second, and also it will show the direction also in which direction the car is moving. Then here you can observe this 16,000 is nothing but a magnitude, and also it will show the direction. Therefore, it is a vector quantity. Here consider the remaining option. Volume, it will show the only the magnitude, only the number it will show. Then mass, already you know, mass it will show only the magnitude, and even density also it will show only the magnitude. Therefore, the correct answer for this question is momentum. It has both magnitude and also it will show direction.